And hello, welcome. Last time we were doing this simulation. Yeah, we already started a very crude simulation of sorts. But of course, the next thing to do is actually to plot graphs, right? You actually want to at least be able to see some results, right? Now we just want to talk about releasing files as a CSV, exporting data to CSV. Okay, I'm going to run cargo watch x dash x run. Okay, cargo watch dash x run again. Okay, so this is what we'll be using to constantly get the outputs. So now I just want to introduce you to this package, or what we call crate. Remember last video we talked about crate. Crates are Rust packages. You can think of it like that. But we just call them crates. Okay. So this crate is called CSV, and you can actually um, use CSV to actually write values. Okay. So how do you use the CSV writer? So there's actually syntax here for you. There's an example piece of code here. So let mute writer equals to writer from path, so on and so forth. Okay. There are some more programming concepts here, but some more advanced programming concepts here that you should know if you want to execute code like this, but we'll leave that for later. Okay, just copy and paste the code and mostly it will work. Okay, however, you see this question marks here? This question marks here and this result here, both of these are related. Okay, I don't want to overload you with information here. Even this OK question mark result, yeah, this OK is also related. So that's actually what we do with the result enums. For now, we'll just do away with that. Don't really need to care too much about that. I'll just show an easy way to deal with this. Not necessarily the best for all situations, but it's good for beginners. Is that kind of way. All right. So without further ado, let's just talk about how to get our results exported to CSV. Okay. So basically, in a CSV file, we should expect two things, right? Okay. We should expect at least two things. Okay. Yeah. If we are plotting using Excel, or in this case LibreOffice, I'm going to use the shift button to make the graphs straight. Okay, so you have let's say y, and over here you have t. So if you want to have the exponential decay graph, you have something like this. So you need to have many points of t and y, and those should be inside your CSV file. Right, so how should we do this? Okay, first thing first, let's get our time step values. Okay, so let's mute let current time step. Okay, so this is what you're probably used to. You don't really get the mutable stuff yet, but let current time step equals to, let's say, something like 0. Okay, so what I want to do here, I will say maybe I will start writing CSV file. So this comment here is to say I want to start writing the CSV file here. So what I want to do is to write something like the time step and the solid temperature, current time step. Okay, current time step and current time step temperature, right? So solid temperature, current time step. Yeah, so this is what the code is supposed to look like. Okay, so that's what we are going to aim for. Then after that, after we start the CSV, then we start calculating. Okay, so we'll start the calculations. So what are we supposed to do before we even start the things? We'll figure out how to write the CSV later, but we need a steadily ascending column of time values, right? So what we start with a time step of 0, and what we need to do is at every time step calculation we will need to update the current time step. So what I'll do is I'll have time step equals to time step plus, okay, sorry, current time step, my bad. Current time step equals to time step, or current time step plus time step. Okay, so what is doing at every iteration or every loop is that, hey, the current time step is 0. I want to update the current time step. You know, it needs to add this time step, right? So we started at 0. We have a delta t time step equals to 0.1. So the first time step is 0, and the next time step should be 0.1. So we need to add this delta t to this time step, this simulation time step. So that's what we are doing here. The current time step equals to the current time step plus the time step. Okay, so current time step is this. Well, we'll need to change it to be mutable in order for in order for this to work. Okay, I'm going to print line, and I want to see the current time step. Okay, current time step. So I will have all the values, right? It goes all the way up to 10 seconds. You can see 10 or 10. We don't know what the unit is, right? So the 10, it goes from 0 to 10. Okay, it starts from 0.1. Okay, it will print out, and 0.2. Here's the value, 0.3. Here's the value, 0.4. That's the value. Now you might wonder why this 0.3 has a 0.3 times and then 0.0004. Okay, this is like a sort of a rounding error or a double addition error, because these are, after all, represented using binary numbers. They don't use a decimal system, they use a binary system. So that's why there's there's kind of an approximate thing right here. But don't worry too much about it. The errors are usually very, very small. Okay, so it goes up all the way to about 10 seconds or 10. Okay, no units yet. Okay, but regardless, we have our information here and we want to start plotting them in our table. Right, so how do we do that? Okay, so we need to actually get this CSV package. So we'll start by learning how to add cargo packages. Okay, to add cargo packages is fairly straightforward. You just use cargo add. Okay, that will add a package to your project. Cargo add and add what? Okay, the package or crate. Okay, we have to add crates. The crate is called CSV. It's that simple. It's just called CSV. So when we want to do cargo add, we'll just do cargo add CSV. And then it will add this and you'll compile it after you start doing a cargo run. So this is a very light package, so not too many dependencies here. Okay, so it'll compile fairly fast, and there you go. Now, how do you actually use the CSV? Well, we can actually take a look. Yeah, if you forget, you can actually take a look here. Let mute writer equals to writer from path. Okay, so as you can see here, let me do here CSV file. As you can see here, the syntax is quite straightforward. Okay, WTR is just writer. It's a CSV writer. You use this writer and colon. Okay, copy paste. Don't worry too much what it is. Foo.csv. Okay, this is, well, by guesswork, you don't even have to know what this package is doing. This is actually your file name. I want to say this is Newton's law because I want to change the name. Now I'm going to save this and you're going to have a problem because of this question mark. Okay, let me show you how to do it. Okay, oh, even before that, the CSV writer here is not even important. They're asking you to import. So go ahead and import, use CSV writer. Okay, and that will enable you to use the CSV writer file. Okay, now you'll complain about the question mark. Okay, this function will return a result or option, or should return a result or option to accept the question mark. Okay, it's a question mark. It's a little early to introduce all of this now. So what I'll just say is that anytime you see a question mark, use this function called unwrap. Okay, use this function called unwrap. 80%, 90% of the time it will work. Okay, now you're actually seeing another problem when you export CSV file. You see that this cargo is continuously running the simulation over and over and over again. Why is that the case? Okay, the reason is that cargo watch actually watches the entire project folder for changes in file. Anytime there's a change in a file, the run command will keep going again. So what's actually happening here is that when you run implicit Euler method, you're actually you're creating a new CSV file right here. See, Newton's law.csv. You're actually creating a new CSV file. And after you create a new CSV file, what happens? Cargo will detect that the CSV file actually has been created. There's a new change to the whole folder directory, and then it will run all the functions again. It will run the command you supplied, and the command I supplied was the run command. So when the next so cargo will actually run the cargo run command again. Cargo watch will run the run command again, and then it will run this run function again. And then this run function will actually make a new CSV file, and then that will cause the cargo watch to just restart. Okay, this is not desirable behavior, so the way to work around this is called cargo watch -- ignore star.csv. Okay, star down here is what we like to call a wildcard, or yeah, it's called a wildcard. It means that if there's any new CSV file that is created, ignore that. Yeah, if you detect a change in a CSV file, ignore that. Every other file that happens to be, changing, cargo watch will watch for that. So it will watch the whole folder for any file change except for CSV files. So this is what this command is doing. Cargo watch -x run -- ignore star.csv. So let me write this down here. Use cargo watch -x run -- ignore star.csv. This is how you do it. Now I'm going to run this, and then the CSV file will be there. Now if you actually open your CSV file, there's going to be absolutely nothing in there. I'm using LibreOffice Calc. It's free and open source software, if I'm not wrong. So the CSV file is empty, so it's not very interesting. We'll need to actually add data to our CSV file. So how do we add data? Okay, we will take a look here. You see writer.write record, and you have this ampersand sign again. All right, what's this ampersand sign? These are references. We'll cover them in a later video. Okay, it's a little bit complex for now. I don't want to introduce too much information too early. So actually, let's just do the write command. Use the write record command. And remember, every time that you see a question mark, for now, just for now, replace those question marks with unwrap. And most of the time, your code should work. Now, what do you actually want to write? Okay, I want to write the current time step. Okay, you see this A, B, and C. These will be actually strings that you're writing, right? But I don't want the strings. I want the current time step and the current time step temperature. So to work with strings in Rust is you need a little bit of knowledge, but my lazy way of doing it is this. Okay, let current time step string equals to current time step to string. Okay, I always use the toString method. Okay, this will usually work. It is not the most optimal way of doing things, but I just want something that works. I'm very lazy. Okay. So what you can see here is that when you write a record, you either write it in terms of string literals, these things in colon, okay, these things in colon, or you use strings, the string type. Okay. So the Rust has two main string types, but there are many more, or rather there are many more. This is called the string type. This is we call this the owned string, and the nster type, which is a borrowed string. This is a pointer or reference. Again, you'll see these ampersands coming more and more often as you delve deeper and deeper into Rust. But for the time being, don't worry. If you have a problem like this and you want to convert nster to string, there are two ways you can do it. Okay, there are two ways you can do it, and I'll just demonstrate it for you. First is to use the toString function. toString. Okay, and that will work because now B is to string and C needs to be converted to string as well. So let me show you the second way you can convert this nstrs to string. So you can use the toOwned function. Use either of these to get this done. Okay, now if you actually look at your CSV record, let's go look at the CSV record, the Newton's law.csv, we will see a very long string, type, okay, a lot of data, at least 100 pieces of data here. And then we'll see the second column being all B's and the third column being all C's. Okay, so obviously we don't want that, but that's just to show you how to deal with these strings or nstrs or strings. So for me, I just convert everything to string. That's a very lazy way of doing it. Not the best way, but I don't really care too much about these different string types for the time being. And for most simulation purposes, I really don't care too much. Okay, you do more Rust, you might need to care about it, but for now, for the purposes of this video, don't bother. Okay, let solid temperature current time step string equals to solid temperature current time step to string. Okay, and let's do this. Solid temperature current time step string. Okay, so now you actually have, if you actually look at your Newton's law file, I'm going to open this and, okay, one more time. Okay, I'm going to open this up. Okay, so you're going to see all your data here, which you can just plot. Now, copy and paste this. I'm going to go to the desktop. Okay, what I can do now is just to add titles. So the one is time and then temperature. This is a nonsense column, which I can just delete later. And now I can just insert a chart. We should be able to see our graph. Finish. Okay. So this chart seems to indicate a decreasing temperature. It looks almost linear. I don't know whether there's an actual problem with it. Is there some kind of error? Why is it a linear profile? Okay, maybe it's too early in the graph. You can see that if you take a look at this part, this part can look a bit linear, and then you still haven't gone to the part where it starts curving down. So maybe what we'll do is to lengthen the time step. Let's lengthen it to about 10 times longer, or maybe 5,000. We'll do 5,000 time steps. Rust will run 5,000 time steps. Okay, it will simulate it to 25 seconds. So let's take a look at that instead. Close this and don't save. I will take the new Newton's law file, put it here, overwrite. Okay. Now we should have more data points. So time, temperature, and you'll see, yeah, now it's cool down all the way to 25 degrees C. You can actually see how long it takes to cool down. So let's do, oops. I'm going to do the function list. How did I? Never mind. Chart. I'll deal with that later. Okay, finish. There you go. There you go. That's what success looks like. All right, let me close this part. Whatever. Okay. Yeah, so look, we have successfully simulated Newton's law of cooling using various crates. Of course, this is not a perfect thing I have not even gotten the time and temperature things sorted out. Okay, I want to introduce the titles. I want to put this in a title. And of course remove the C. Okay, that's it. But look, the data is there. The data is there. We have a good cooling curve. We have simulated first order ODE. Yeah, simulated it numerically, no problem, using the implicit Euler scheme. Okay, it works. Okay, but let's just do some tidying up before we call it. Okay, yeah, rather not tidy up, it's like more, it's not done yet. Okay, first thing first, I don't really like to have this C here. Okay, I don't like having this C here. Okay, let me remove that comma as well. Okay, but yeah, I think more or less it's done. We don't need the print lines anymore, the print line things anymore. So I'm not going to have them. Oops, one more. I'm not going to have them. So make it really nice and clean. Okay, and then of course, yeah, this is the Rust code that helps us to simulate a Newton's law of cooling. Okay, so I'm going to call it a day because hey, I mean that's quite a lot we've learned already. We learned how to import CSV files. We learned how to use the unwrap thing, but we don't deal with the result parts anything yet. We learned how to deal a little bit with strings. We learned how to deal with strings at least. Okay, we learned how to deal with strings, and we learned how to write records using the CSV crate. Right, so that's pretty good. We done a simulation and can do post processing. All right, okay. I think that's enough. See you next video. Bye bye.